All right, guys, this is round two. Tried to do a one take wonder last night, period three. I'm so sorry you had to watch a video that shut off after 20 minutes and the audio died quickly thereafter if you got it to come back. But I'm going to give it another shot. So, period two and six, you guys will be watching this tomorrow. Period three, this is probably Friday for you, unless you're watching it tonight. So, what are we talking about today? We're talking about money, banking, and monetary policy. Well, no, I'm just now reading. That's the unit that we're on. What are we doing today? We're going to talk about bank balance sheets and how banks can artificially increase the money supply or the expansion of the money supply through the banking system. So, the first half of this lecture, we're going to talk about how banks record their assets and liabilities. That way, we can manipulate some bank balance sheets and see how the money supply can grow. Sound good? Cool. Here we go. So, topic 4.4 banking and the expansion of the money supply. So, let's go with starting with the banking system. So, the banking system that we use in the United States and most developed nations, all nations, is the fractional reserve banking system. And the fractional reserve banking system is exactly what it sounds like. Fractional reserve banking system is a situation when banks hold on to just a small portion of deposits to cover any potential withdrawals and then loans out the rest of the money. So, what does that mean? That means banks have thousands of customers. Across the street, we have Bank of America. I'm going to assume they have 5,000 customers with that Bank of America. When any customer goes into that bank, they deposit X amount of dollars. The bank doesn't keep all of their money in their vault, in their cash registers, or on file at the Federal Reserve Bank in San Francisco. They keep just a little bit and they loan the rest of that money out to other people. Why would they do that? Well, that's how banks generate revenue. Banks pay their employees, they pay for their rent, they pay for the electricity, everything comes off of revenue from loans and bonds and other interest bearing assets that they purchase. Now, they do that with our money. So, only a fraction of my deposit stays in the bank, the rest goes out. Now, you're thinking, well, what happens if everybody goes in to withdraw all their money at the same time? Well, the bank doesn't have that money. And that's what you guys looked at in the Great Depression in APUS when you had a bank run. Everyone said, oh, the banks are failing. I better go get my money. Well, banks don't have enough money for everybody to come get their money out. But if there's 5,000 customers in this bank and everybody, well, the bank holds on to 10% of everybody's deposit, then it's safe to say that people can go about their transactions on a daily basis. Maybe a few customers can withdraw all their funds, and that 10% of the deposits of 5,000 customers will cover all of those transactions and all those withdrawals throughout the course of the day. So, what do we have in a bank balance in a bank to record our assets and liabilities? We have what's called a bank balance sheet. And a bank balance sheet is a record of bank's assets and liabilities. Usually it's in the form of what's called a T chart. We have assets and we have liabilities. On one side, we're going to have demand deposits. I'm going to represent that as DD for right now. And on the other side, we have required reserves and we have excess reserves. So, what are demand deposits? A demand deposit is money deposited into a commercial bank into a checking account. This is that term I talked about in our Intro to Money lecture that's super confusing because there's 4 different names for demand deposit accounts. There's a demand deposit account, there's a checkable deposit account, you could call it your checking account. All of these 3 things also relate to checks and your debit card. So anytime a customer puts money into a bank that they can access through a debit or a check, we call that a demand deposit, a checkable deposit, a checking account. Well, since we're talking about the fractional reserve banking system, we're going to say that banks have to hold on to your money. Now, the required amount is called the required reserve. That's the percentage of the demand deposit that a bank must hold by law. Say, for example, the demand deposits in this account are $1,000. And in our banking system, there's a 10% required reserve. That means this bank would have to hold on to $100 of the total demand deposits in this bank. What's left over? We call that the excess reserves. That's the amount of money that banks can loan out, they can buy stuff with, they can use as they see fit. Demand deposits are our customers' deposits in that bank account. Required reserves are the amount that the bank must hold. There's a percentage required reserve ratio that says we got to hold on to 10%. So the required reserves in this case are $100. What's left over is the money that this bank can use to generate revenue. So the question is, are demand deposits in a bank an asset or a liability? Well, it depends on your perspective, right? To a bank, demand deposits are going to be a liability. Why? That $1,000 belongs to its customers. Let's say this bank has two customers, Mr. Owen and Mr. Drake. Well, 500 of that is mine, and 500 of that is Mr. Drake. Those are our assets that we put in the bank. The bank is using my money for something, but it has to give it back to me if I demand it. So, a demand deposit for a bank is a liability. For the depositor, Mr. Owen and Mr. Drake, it's an asset. So that brings us to the next point of view. A bank balance sheet is going to be recorded from the point of view of the bank. This is flipped or reversed from what you might have in your accounting class or a finance class. So bank balance sheet time. Bank balance sheets are often called T-charts. Why? Look at that T I drew in the middle. Boom, I'm a T. What's up? It can spell T or tree or tree. So the bank balance sheets are always going to be balanced. As we can see in this sheet right here, both sides hold a value of $1,000. 100 plus 900 is 1,000. Demand deposits are 1,000. This is a balanced balance sheet. We are happy. They're always going to be prepared from the point of view of the bank. Again, we know that because a demand deposit in terms of a bank's point of view, a demand deposit is a liability because Owen or Drake might come get it. Reserves are assets to a bank. They're using these. Cool. Simplified bank balance sheet number 1. So here we have a demand deposit account of $1,000. We have required reserves of $200. We have excess reserves of $800, and they all add up to 1,000. Whereas, what is the required reserve ratio in this economy? And again, the required reserve ratio is the amount by law that the bank must hold in required reserves. So how am I going to solve that? I'm going to say, all right, the required reserve is $200. The total demand deposits equal 1,000. So my required reserve ratio is $20. Bank balance sheet number 2. All right, so each one of these balance sheets, let me scoot this bench back a little bit. Each one of these balance sheets are going to start with the same starting point. That's why it's simplified. Again, demand deposits are 1,000, required reserves are 200, excess reserves are 800. What's going to happen if Mr. Cornforth adds $500 to this bank balance sheet? Well, I know my demand deposits are 1,000. My required reserves are 200. My excess reserves are 800. And my loans are 0. We haven't made any loans yet. Well, if I deposit $500 into the bank, and by me, I mean Mr. Cornforth. If he puts $500 into this bank, 500 goes in on this side, 500 is going to have to go in on this side as well. But where's it going to go? It's not going to all go into excess reserves, because if my demand deposit increases by 500 and I have a 20% required reserve ratio, then my required reserves are going to have to change. So you can add it on and then solve, or, and I find the easiest way to do it is I take a look at the total deposit and say that, all right, 20% has to go into the required reserve. So what's 20%? of 500? That's right. It's 100. Thanks for answering out loud. So what can go into the excess reserves? If my total deposit is 500, 100 is going to go into my required reserve. What's left over? That's $400 that's going to go into the excess reserve. You can check your work by seeing if they add up. 400 plus 100 is 500. So my required reserve is going to increase by 100, taking it to 300. My excess reserve is going to increase by 400, taking it to 1200. So here's how I would have shown it if I was in the classroom. Corn force deposit is 500. 500 times 0.2 is 100. That's our required reserve over here. I took my total deposit, 500, minus required reserves, and I get my excess reserves. So my excess reserves were 400. I added that to my 800. I added 100 to my 200. And now I can say, all right, my required reserve increased by 100. My required reserves are $300. My excess reserves are $1,200, and we're good to go. If you wanted to check your work and see if our required reserve ratio is correct, you can say, all right, what's 300 divided by 1,500, and find out if that's 20%. In which case, if we want to do it just for the sake of trying it out, let's give it a shot. Let's say 300 divided by 1,500 is 20%. So far, we're all good in the hood. Next page. Period 3, notice that I'm using lined paper to keep my camera focused this time. Things I forgot from distance learning, or maybe I chose to forget. All right, we have the same balance sheet again. What would happen if Mr. Troop wrote a check for $400 at Best Buy? When you write a check, that's money coming out of your demand deposit account. That's money coming out of your checkable deposit account. That's money coming out of your checking account. It's the exact same thing as Mr. Troop swiping his debit card at Best Buy. So that means both sides are going to decrease by 400. So far, so good? All right. So I know I'm going to take 400 out of 1,000. But how much am I going to take out of the other side? I'm going to have to readjust my required reserves, and I have to readjust my excess reserves. So let's figure out how much we have to subtract each side by. So back to Mr. Calculator friend. Hey, friend. So in this case, I've got $400 that's coming out times by 0.2. All right, I'm going to take $80 out of the required reserve. Now, if I want to find out what is my excess reserves, I'll take my total withdrawal minus what's coming out of the required reserves, 80. So 400 minus 80 is 320. So I know that if I want these balance sheets to balance, I'm going to have to subtract 400 from my liabilities and 400 from my assets. I'm going to take out 80 from my required reserve, and I'm going to take out 320 from my excess reserves. Now my total assets add up to 600, and my total liabilities add up to 600. I have two balanced balance sheets. So we are looking good here. First example was money going into a bank. This was money coming out of a bank. What if this bank decided to loan out $500 to Mr. Drake? Mr. Drake wants to buy something for $500, probably a golf bag. So if Mr. Drake wants to take out a loan for $500, is that going to change the required reserves? Actually, step one. Is it going to affect demand deposits? It's not. Demand deposits are people putting money into the bank to hold it in their account for the use of checks or debit cards. Probably a Venmo connected to it as well. It's not going to affect demand deposits whatsoever. So if demand deposit doesn't change, required reserves isn't going to change. What do banks want to do in the fractional reserve banking system? They want to make loans. They want to buy interest-bearing assets to generate revenue. By law, they have to hold money here, and whatever's left over, they can do what they want with. That's where excess reserves come in. Now this bank is ready to put itself into a good financial situation and start generating revenue. They have $800 of excess reserves right now that they could do whatever they want with. 500 is going to turn into loans that go to Mr. Drake. So I'm going to subtract $500 from my excess reserves, and I'm going to drop it in my loan category. So my excess reserves now hold a value of $300. This represents a loan that is in the hands of Mr. Drake. Mr. Drake has a $500 loan. He's going to pay it back in a few years at a specific interest rate. But as of right now, this bank no longer has access to that $500. That money is gone. It didn't change the demand deposits. Therefore, it didn't change the required reserves. What it did change was the excess reserves. All right. What would happen if the bank decided to invest $200 in government bonds? Government bonds will also be referred to as government securities in this course. So again, if the bank decides to invest in government bonds, that means they're buying government bonds. They're buying an IOU from the government for the value of $200 that the government will pay back in X number of years at a certain interest rate. So that's an asset. Right now, there's 0 bonds owned by the bank. They're about to buy $200 worth. So we'll take 200 out of the excess reserves and ploop, drop it into the bond category. 800 minus 200 is 600. 0 plus 200 is 200. They're still adding up to 1,000 in the assets and 1,000 in liabilities. So I have 2 balanced balance sheets. All right, let's flip it. What's going to happen if my answer key is right there on the thing. Well, there's the answer. What would happen if the Federal Reserve bought the bank's bonds? Now we're looking at a bank that has $1,000 in demand deposits, 200 in required reserves, just like every other example. But in this bank, the bank has already invested in $700 worth of bonds. Now, sometimes the government wants to buy its bonds back. In this case, if the Federal Reserve decides to buy the bonds back from the bank, Federal Reserve says, "Yo, Bank of America, do you have any bonds?" "I sure do. I have $700 worth of bonds." They said, "Well, we would like to buy them from you." Cool. This is the bond. They're going to hand it to the Federal Reserve Bank. The Federal Reserve Bank will give them money back, right? Interest-bearing asset goes to the Federal Reserve. The Federal Reserve hands cash back to the bank. Since the required reserve is still satisfying the 20% required reserve ratio, that money is going to go from the bonds bloop, bloop, back into the excess reserves. Now the bank can do whatever it wants with that money. Maybe it can make a loan to Mr. Drake. Maybe Mr. Owen needs some money. But what do we have here? After the Fed buys those bonds, required reserves stay the same. Excess reserves are now 800, and the bonds are now 0. What are the keywords that we care about in our bank balance sheets? Checkable deposits, demand deposits. Those are the same 2 things. It could even be checking account, but rarely you'll see that. Required reserves, we like those. You've seen that we've been using that. Excess reserves, we like those. Sometimes they'll refer to a total reserves, in which the case they'll call it reserves, which means reserves are broken up into 2 parts: required reserve, excess reserve. You add the 2 together, you get total reserves. Okay? And we're going to see a lot of problems where we're going to have to manipulate these 2 things. And sometimes they don't separate them. Sometimes they just give you this. We'll see it in some practice problems. We care about loans, and we care about government bonds, aka securities, or in this case, government securities, aka bonds. Everything else is a distractor. We might see a problem that says things like owner's equity. That just means, it doesn't matter what it means. If you want to do further research, check it out. We might see plant and fixtures. We might see furniture. We might see a lot of things on a bank balance sheet that don't relate to what we're going to manipulate in this class. It's practice time. Practice time. Flipping the page. Keep it focused. Keep myself focused, then keep the camera focused. Practice number 1. and there's a friggin' answer on it. I thought this was my substitute edition. I guess it's not. Bummer. All right, so we're gonna roll with it anyway. Let's see. So what do we have? We had a bank balance sheet with $1,000 in the demand deposits. They had reserves, not required reserves and excess reserves. They just have reserves. So again, reserves. We've got required reserves, and we have excess reserves. We got bonds and we got loans. What question did they ask us before I shamefully revealed the answer? What are the excess reserves in this bank? So let's figure it out. We know that it says right here that the required reserve ratio is 10%. So what is 10% of $1,000? $100. So if the required reserves are $100 and the total reserves are 150, total reserves minus required reserves will give us our excess reserves, because required plus excess equals total. In this case, what are the excess reserves? 50. Hopefully the next question doesn't have the answer next to it, because I did remake this last night before the son of a biscuit. All right. I'm going to just go with it. This is the world I'm living in right now. I can't make this video a third time without having a mental breakdown. You're seeing The Verge. There's the Trimmer, a freak out happening right here. So let's see what's going on here. The answer is 0. But what are the excess reserves? Same exact balance sheet. Check it out. 1,000 in deposits, 100 in owner's equity, 150, 275. All I did here was just change the reserves down to 100. So again, my reserves, I got my required reserves, my excess reserves. I'm still operating with a 10% required reserve ratio. This bank must hold 10% in required reserves. 10% of $1,000 is $100. The total reserves in this bank are $100. Therefore, my excess reserves has to be 0. 100 plus 0 is equal to 100. God dang it. This is very frustrating. But we're just going to go with it. All right. Refer to the data above. This commercial bank has excess reserves of... All right. So we have, once again, reserves. Required reserves. Excess reserves. What is the total demand deposits in this account? 110. What is my required reserve ratio? It's now 20%. Oh gosh. There we go. This means my required reserve ratio, or my required reserve, is 20,000. Currently, my total reserves are 27,000. My reserves are made up of my required reserves and my excess reserves. If I want to find out the excess reserves and I know my total and my required, I'll subtract my required reserves from my total. So 27 minus 22 will give us excess reserves of $5,000. I bet you if I just go to present mode, the answer is going to show up. I just don't want to jinx this video and have to refilm it. So I'm going to roll with what I got. Okay, 14%. There's your answer. So what the heck did this question ask us? All right. Refer to the table above. This bank has excess reserves of $6 million. Then the legal reserve requirement ratio must be. Ooh, all right. So we're working in opposite. So let's see. Reserves. Our total reserves are $20. If this bank has excess reserves of 6 million, that means my required reserves are 14 million. Why? 14 plus 6 is 20. So how do I determine the required reserve ratio? I take the required reserve, divide it by how much is in that bank, $100 or $100 million. So 14 divided by 100 is 14%. And that's how we got 14% right here. Here comes another answer. There it is. It takes all the fun out of it when you give away the surprise. It's like reading the end of a murder mystery at the very beginning. Never actually done that. I don't know if people really do that. That's just lame. Assuming a legal reserve ratio of 20%, let's put our information down. So my reserve requirement ratio, that's 3 R's. That's fun. Is 20% equals 20%. How much reserves will this bank have after a check for 10,000 was drawn and cleared against it? All right, there's a bug on my screen. So, trick question here. So a check was drawn against it. That's like when Mr. Troop went into Best Buy and spent $400. So I'm going to just mess with a table real quick. We got assets and we got liabilities. Checkable deposits, I've got 130,000. And I've got reserves, total reserves of 40,000. Somebody came in or somebody went and spent $10,000. So 10,000 has to come out of this side. And 10,000 has to come out of this side. So now I know that my reserves equal 30,000. They want to know, let's see, what are the excess reserves left over? You can't see my screen. My head's in the way. No, wrong way. This is not helping. Here's the answer to my problems. Yeah, move the camera. Way to go, Mr. Owen. All right. So it said, how much excess reserves will this bank have after a check for 10,000 was drawn and cleared against it? I took 10,000 out. I took 10,000 out. Now I can figure out the required reserve ratio, right? So in this case, I now have 120,000. My required reserve ratio is 20%, so times 0.2. That means my required reserves are 24,000. Still good? My total reserves are 30,000. So these two have to add up to 30,000. 30 minus 24 gives me my excess reserves of 6,000. Sound good? Mental break. Pause it if you need to. Rolling with it. Pause. Unpause. There you are again, Duckleham Lincoln. Cool. This is my mental break right now to make me feel happy. Nice. Mr. Owen's in a happy place. Time to start learning again. All right, part 2. Expansion of the money supply. So this is the part that might get a little tricky. You're going to have to take off your practical thinking side and put on your Duckleham Lincoln abstract thinking side. Because we're going to talk about artificially created money and your mind is going to be blown. But you got to accept where I'm going with this. And I'm going to try and explain this clearly. But you never know. We're going to talk about a model deposit creation. So when a commercial bank receives a cash deposit, the bank's ability to increase loans begins a new chain of loans that can lead to a multiplied increase in demand deposits and in the money supply. What the heck does that mean? Well, that means this bank just receives $1,000, just like we've done so far. When that money goes into a bank, part of it gets held in the required reserves, right? Let's say in this case, it's 10% to keep Mr. Owen's math simple. $1,000 goes into this bank. 100 has to be saved in required reserves. The other part goes into the excess reserves, like 900 bucks. This money can be turned into new loans. Somebody is going to get that money and they're going to take it and they're going to spend it. When they spend it, someone's going to receive that money and say, "Sweet, I just got 900 new dollars." They're going to put it in the bank. That bank has to hold on to 10% of that. So they're going to hold on to 90 bucks. And then they are going to loan out the remainder, what would be the excess reserves. Now here's the problem. Mr. Owen originally put that money in the bank. That money went into the bank, and any time I can go back to that bank and say, I demand my deposit back. I can get my $1,000 back. But what happens if the bank loaned out my money? That person took my money and they spent it. So they gave my money to Mr. Wade. Mr. Wade said, I'm going to buy something from Miss Neubauer. I'm just going all the way down the hallway. I'm going to buy something from Miss Neubauer. Miss Neubauer draws puzzle pieces, child puzzle pieces. She sells that to Mr. Wade. She now has $900. She's happy. She sold something of hers to Mr. Wade for $900. Her income, her wealth has increased by $900. But I can still go back to the bank and pull out my $1,000. So the bank artificially created $900 because of the fractional reserve banking system. The other customers in the bank have now covered that expansion of the money supply. I can have my $1,000 back. When I take my $1,000 back, they're not going to revoke Wade's loan and ask Neubauer for that $900 back to pay me. Neubauer's got that 900, and I've got my 1,000. So the money supply has been artificially increased. The extent of this maximum multiplied, the extent of the maximum multiplied increase is directly tied to the required reserve ratio. That's a wordy sentence. What does that mean? Well, it means this isn't the end, right? Someone is going to get a loan for 810. They're going to spend it. They're going to put the money in the bank. Bank's going to loan out more money, and it's going to continue and continue. The money is going to be multiplied into a maximum amount. So, and that is related to the required reserve ratio. This bank had to hold on to $100. They saved $100. Therefore, they could loan out the rest of it. If banks have to hold on to a small amount of money, then the increase in the money supply is going to grow at a very large rate. If the banks have to hold on to a lot of money, then the increase in the money supply will be smaller. A good way to look at it is that required reserve ratio right here, or what is being held, is just like my MPS. And we talked about the spending multiplier, and the spending multiplier was 1 over MPS. The smaller the MPS, the greater the spending multiplier. When banks put money in their required reserves, they're saving money. If the required reserve ratio is low, then the maximum increase in the money supply is going to be great. If the required reserve ratio is high, the maximum multiplied increase in the money supply will be low. We'll prove that out right now. But let's take this definition and this graphic right here and put it into the full effect, into the PowerPoint. Not like that. Like that. So again, I'm going to go with a $1,000 deposit from person A. The required reserve ratio is still 10%. I'm going to repeat this example. Assume person A deposits $1,000 of cash, which they originally had in their home. I had $1,000 just sitting in my home. Treat yourself around the world. I wouldn't go put it in the bank. I'd probably just spend it. But let's pretend I'm financially responsible, and person A puts $1,000 in of cash into the bank. the bank has to hold on to 10%, that required reserve ratio. Therefore, they put $100 in the reserves, the required reserves. This means $900 can be loaned out to person B. What does person B do with it? Person B takes that loan and hires a contractor, person C. Person C builds a deck. Person B pays that person for that deck. Person C now has an increase of wealth of $900. At any point, person A can go get his $1,000 back, and person C still has their $900. So the money supply has increased. The bank is going to hold on to $900 when person C deposits it in the bank, and they're going to take a portion of it, loan the rest out. So the bank loans out $810 to person D, and person D is like, you know what? I took out that loan. I'm going to get that medical procedure I've always wanted. And so they're going to pay a physician, person E, $810. That physician just received an increase in their wealth. They're going to put it in the bank. The bank's going to hold on to 10%, and they're going to loan out the rest. So the bank holds on to 81 bucks. They loan out 729, and the money supply has increased again. We've run through 3 different banks and 3 different deposits at this point. First deposit was $1,000. Second deposit was $900. Third deposit was $810. At each stage or at each deposit, the reserves have grown. So 10% of 1,000 is 100. 10% of 900 is 90. 10% of 810 is 81. From each deposit, new loans were now possible. Those new loans represent new money. That's my money and someone else's money at the same time. So an initial new loan is our first instance of money being created. So $900 was artificially created off of my deposit. Then $810 was created off of $900. And $729 was created off that $810 deposit. At each stage, the new loans that come off of someone else's money is artificially created money. And this is going to go on and go on and go on until there's no money left from that initial deposit left to loan out. So once everything is locked into the reserves, the chain ends. The initial deposit was $1,000. Once my reserves equal $1,000, the maximum increase in the money supply stops. That $1,000 is going to expand all the way to $10,000 in this economy with a required reserve ratio. We'll explain why, of 10%. We'll explain why in a second. The new loans in this economy will expand or be multiplied all the way out to $9,000 in this economy based off of a 10% required reserve ratio. So the 9,000 in total new loans represents new money that's been created by the bank as a result of that deposit. This is the maximum increase in the money supply. Why? Because this was the first stage of new money. So let's see how this works. So if I want to determine the maximum increase in the money supply, I'm going to take the initial new loans times a money multiplier. What's the money multiplier, my friend? The money multiplier is 1 divided by the required reserve ratio. The required reserve ratio is the amount of money that banks have to save. So the required reserve ratio is just like our MPS, which makes our money multiplier just like our spending multiplier. So in this case, from a $1,000 deposit, the initial new loans that can be made after a bank puts away its $100 that it has to legally save or hold as required reserve gives me $900. That's what I can loan out. That's what goes into excess reserves. Mr. Owen puts $1,000 into this bank. In the required reserves, I have to hold on to $100. $900 goes into excess reserves. Excess reserves can do anything. We can buy bonds with it. We can make loans with it. We can do whatever we want. If this bank makes loans of it, that initial new loans is our new money supply that's being granted. Comes out of that. This has to stay in the bank. So my initial new loans times the money multiplier will give me my maximum increase in the money supply. So what's our money multiplier in this setup? It's just 10. My money multiplier equals 1 over my reserve requirement ratio, or 1 divided by 0.1. So my money multiplier is 10. What's the total amount of deposits? Now, I'm only giving you this one. It doesn't really matter for the course of this unit, but College Board likes to see if you can distinguish new money from new deposits. So they will ask you this question. It's tedious and silly, but they're going to do it anyway. So the total amount of new deposits will be your initial deposit, in this case, $1,000, times your money multiplier. So 1,000 times 10 is 10,000. In theory, they could ask you what is going to be the total change in reserves as a result of a $1,000 deposit at a 10% required reserve ratio. I've never seen that question, but they could ask it. And in which case, you take your new reserves times your multiplier, and you get 1,000. And it would be the same amount as your initial deposit. Let's practice. All right. Big pen's working, but I'm definitely wasting the earth. Mr. Owen deposits $500 into his checking account at Bank of America. $500. That's awesome. Part of it has to go into required reserves. The rest can go into excess reserves. That becomes the new loans. That becomes new money. I wish that was like my gangster name. Call me New Money. All right, so what is the initial new loans this bank can make, assuming a 20% required reserve ratio? What's 20% of 500? 100. 100 has to stay in this bank. What goes into excess reserves? The remaining balance of that deposit. 500 minus 100 is 400. So what is the initial new loans that this bank can make? $400. What's the maximum increase in the money supply? Well, my equation was my initial new loans, $400, times my money multiplier. My money multiplier is 1 divided by 0.2. My money multiplier is 5. 5 times 400. The maximum increase in the money supply as a result of Mr. Owen's $500 deposit into the bank is $2,000. How did I write this out here? I said $400 initial new loans. I did 500 times 0.2 is $100. That goes into required reserves. I take the total deposit minus what went into the required reserves, and that gave me $400 in excess reserves. That became new loans. That's my answer to number 1. The second number 1, and why it's called the second number 1 makes no sense to me, but sometimes I make some baloney PowerPoints, was what's the maximum increase in the money supply? Your total change in the money supply is equal to your initial new loans, $400, times your money multiplier. 5 is $2,000. Practice 2. Oh, you can see that red still. Let's try and save the earth a little bit and work from the top of this paper. Mr. Ashby deposits $1,000 into his checking account at Bank of America. It's almost like I'm being paid by Bank of America to keep saying Bank of America, and I get a little commission every time I say Bank of America. How many times did I say Bank of America in that last sentence, concluding that Bank of America and the one I just said? 5. So $1,000 goes into the Bank of America. 6. This banking system has a 10% required reserve ratio. What's the initial new loans this bank can make? Well, 10% of 1,000. This bank, by law, has to hold $100 in required reserves. That means excess reserves is going to increase by $900, which means my increase in new loans is going to go up by $900, which means my gangster name new money is $900. So the answer to number one is $900. And my gangster name is still new money. What is the maximum increase in the money supply? I'm going to take my initial new loans times my money multiplier. In this case, I've got $900 in initial new loans times my money multiplier. My money multiplier is 1 divided by 0.1. So my money multiplier is 10. I feel like that's a better gangster name. Call me money multiplier. So 900 times Mr. Owen's gangster name equals $9,000. 900 in initial new loans, 1,000 times 0.1 is required. 1,000 minus 100 is my excess, which becomes new loans. Total change in the money supply equals initial new loans times the money multiplier. $9,000 is a result of a $900 initial new loan times the money multiplier. Beep boop. Here we go. Let's keep it rolling. It's Mr. Wade's turn. Everybody gets a turn to get some cash. All right. So Mr. Wade deposits $500 in his checking account at Bank of America. Man, I am getting paid. I'm the money multiplier. The banking system has a required reserve ratio of 25%. Now, why would I do that to myself? That's just going to make math suck a little bit. So 25% of 500 is 125 bucks into my required reserve. This bank cannot touch that $125. What can they touch? They can touch the excess reserves. And my guess is that's 375. I'm going to double check that after writing 4G yesterday and embarrassing myself publicly and recorded. So let's go 500 times 0.25. Okay, it is 125. We're still good. 500 minus 125. Yeah! Mr. Owen 4G right there. So excess reserves, that is my new loans that can be created. Or Mr. Owen's first gangster name, my new money. So my initial new loans that the Bank of America can make are $375. The maximum increase in the money supply, $375. My initial new loans times my new gangster name, money multiplier. In this case, it's 1 divided by 0.25 or 4. 375 times 4 is definitely going to warrant a calculator this time. 1,500 bucks. Notice that a high required reserve ratio resulted in a low money multiplier. A low required reserve ratio resulted in a high money multiplier. And by there it is. Low reserve requirement ratio, high money multiplier. High required reserve ratio, low money multiplier. The more you have to put away, the less you can loan out, the less it'll expand in the economy. There's the answer key right there, just in case you want to check that sucker. All right. Still looking good. We all happy here? Cool. Trick question time, and awesome. I don't know how I'm going to be able to show you this one without it. So here comes the answer. Looks like we're playing that answer game again. So the central bank, in the United States, we call that the Federal Reserve Bank, purchases $1,000 worth of bonds from Bank of America. The banking system has a required reserve ratio of 20%. All right, let's see if we can set that up and make this make sense. So we got 20, nope, I almost 4G'd that. 20% assets, liabilities, demand deposit account. Let's give this bank $2,000. 20% of $2,000 is, I think, 400. 2,000 times 0.2 is 400 bucks. So let's say my required reserves are 400. We know that there are loans of 1,000 in this case because the bank's going to buy them. So let's say, no, bonds of 1,000. So what's left over? That would be excess reserves of 600. So we have a balanced balance sheet now, right? Now, this bank bought bonds. Sometimes banks buy bonds instead of making loans. Why? Because, well, Mr. Owen, I may not fulfill my requirement and pay that loan back. I might, declare bankruptcy. Now, if the bank puts all of its money in loans and there's a financial collapse and I can't pay off my loans, if I default on my loans or if I go bankrupt, well, then the bank put all its eggs in one basket. So banks are going to diversify and have different types of assets to cover their bases, right? So you might have some loans, you might have some bonds. Bonds are very safe. They generate a lower rate of return, but the federal government's not going to default on its loans. I say that right as we, raise the debt ceiling temporarily, but that's a whole nother issue. We're going to assume the fact that the federal government's safe. So if the Federal Reserve comes in and buys bonds from this bank, is that going to affect the demand deposits? It's not, right? Demand deposits are Mr. Owen putting money into the bank, Mr. Drake putting money into the bank, Miss Neubauer putting her money into the bank, Mr. Wade putting his money into the bank. That's what creates the demand deposits. By law, the required reserves come from the percentage of the demand deposit. So this isn't going to change. So the required reserve is not going to change. The bond is just an interest bearing asset. Back to my puzzle pieces. This was my interest bearing asset, my pen. The Federal Reserve's like, yo, I like your interest bearing asset. Can I buy that from you? And I'm like, yeah, sure, why not? So I, as a bank, am going to hand my interest bearing asset over to the Federal Reserve Bank, and they're going to hand me cash money. There's my new gangster name. They're going to hand me cash money. Now, that cash money is going to go into my excess reserves. Why? Because that's what I can do with it. It doesn't go into required reserves. That's just going to stay 20% of this demand deposit. So this is a trick question. So my bonds would go to zero, and my excess reserves would increase by 1,000. So my initial new loans that this bank can make, if the Federal Reserve comes in and buys bonds, they just increased my ability to make loans of $1,000. I now have $1,000 more of excess reserves that I can loan out into the economy. So $1,000 in initial new loans can be made after the Federal Reserve purchases it. They could also do 1,600 if they loaned everything out, but we're just basing this off the $1,000 purchase. What's the maximum increase in the money supply as a result of that $1,000 purchase of bonds? I'll take $1,000 times my money multiplier. In this case, that's 1 divided by 0.2 or 5. And we'd say as a result of that $1,000 purchase of bonds by the Federal Reserve Bank, the money supply would increase by $1,000. The bank could loan all of that out, in which case that would just be 1,600 times 5, and that would require me to turn the calculator back on. But that's not what the question asked. They just wanted to know what is the initial new loans that the bank can make off of that purchase. So, cool. So that's how banks create money. Every example we've had up to this point, we've assumed that the bank is going to loan out everything they got, and we're going to have a maximum expansion of the money supply. The first example, we had $1,000 at a 10% required reserve rate. This bank has to hold on to $100 in required reserves. 900 goes into excess reserves. Initial new loans of 900 times my money multiplier at a 10% required reserve ratio. Oh, you can't see any of that. That was really great. 1,000. 100 is held in required reserves. 900 is going into excess reserves. If we take our initial new loans times my money multiplier of 10, 1 divided by 0.1, we'd say that the maximum increase in the money supply is $900. Well, sometimes that $1,000 is not going to result in a $9,000 maximum increase in the money supply. Why? Well, sometimes banks want to keep excess reserves. If a bank decides that they're not going to loan out all $900, maybe they want to keep $200 in their excess reserves, so they just loan out $700. Well, they only loan out $700. $700 times my money multiplier would give us an increase of $1,000 in the money supply. Why wouldn't a bank want to loan out all of its money? Well, maybe they can't find credit-worthy customers. So in the absence of sufficiently credit-worthy customers, a bank may keep some of its excess reserves. In this case, they kept $200 of it. This happened right after the 2008 housing bubble when we went into the Great Recession. Banks had lots of excess reserves, but nobody to give it to. Mr. Owen walked into a bank. This is a joke. Mr. Owen walked into a bank. He's like, I would like to take out a loan. And they're like, okay, cool. What is it that you want to take out a loan for? I'm like, I want to start a business. And they're like, okay, can we see your credit rating? And I'm like, yeah, it's this. And they're like, that? And I'm like, yeah. And they're like, how many bankruptcies have you had? I'm like, 4. Like, really? I'm like, yeah. And then 2 cars have been repossessed. What? Homie, we're not giving you any money. I thought your name was Money Multiplier. That's right. It's a fictitious name. No one's going to loan me any money if I have bad credit or they don't think I'm going to repay my debt. So sometimes banks don't loan it all out. We'll explain another reason why in a future lecture. But as far as right now, let's say we don't loan out all of our excess reserves. We don't loan out the total 900. We won't get a $9,000 maximum increase. If we only loan out 700, we'll get a 7,000 maximum increase. The next one would be maybe you get paid and you don't put it all in the bank. In my first example, I had person A took out a deposit of $1,000. Person B took out $900 to pay person C to build the deck, right? The patio in front of their house. That contractor's like, sweet, I got $900 of new money. He was thinking about putting all $900 in the bank, but maybe he kept $100 in cash because he was thinking maybe I should keep this in my pocket just in case, a rainy day, I get stranded, whatever. Well, if he only puts $800 in the bank instead of $900 in the bank, then they're going to have less money to loan out. Bank 2 would only be able to increase its loans by $720. That's 90% of the 800. Instead of 810, which was 90% of what it could have been if he put all of his money in the bank. So if he keeps some money as cash in his pocket, in his house, probably in the cushions of my couch over here, well, then the bank can't multiply it if the bank doesn't have it. So we call that leakage to coin and currency. And finally, time. This process takes a long time for the maximum increase to happen, right? Multiple people have to deposit money into banks, multiple loans have to come out, in which time people may be paying off those loans and it might all get reciprocated. Time is a lame one. I like leakage to cash and coin, and I really like not loaning out full excess reserves due to lack of credit sufficient customers. Credit worthy. Insufficient number of credit-worthy customers. There's the sentence I'm looking for. Sometimes you just keep changing it around until the words come into the fact. Money multiplier. So here we go. We're going to wrap the class up with an FRQ. So if I was you, I'd pause it right here. I'm just playing. I didn't really pause it. Push the button. All right. So I'm just going to start going it because I'm assuming that you pause it when I... All right, the dad jokes have got to stop. I'm just going to go forward with this, okay? So this is me, Terra Bank. What's the required reserve ratio on this bank? Required reserve ratio is my required reserves. Sorry, I'm pointing as if you can see my finger. Required reserves divided by my demand deposits. In this case, 10%. 10,000 minus 100,000. If Luis withdraws $5,000 in cash from his checking account at Me Terra Bank, how much will the reserves change based off of Luis's withdrawal? Trick question. Did they say required reserves? No. Did they say excess reserves? No. They just said reserves. If 5,000 comes out over here, 5,000 has to come out of total reserves. It's not going to come out of loans. Someone took out that loan. You're not going to call up somebody like, yo, hey, Luis pulled out some money out of his account. Hey, I need you to pay back $5,000 worth of your loan ASAP. But no, I have 5 years to pay that off, right? So it's got to come out of reserves. How much? It's got to equal. So it's just going to be $5,000. Question three gets more, point three gets more specific, and we'll do the solving. Point two, let's see if we paid attention to that lecture on types of money. What is the initial effect of the withdrawal of M1? What is the initial effect of the withdrawal on the M1 measure of the money supply? Explain. When they say the measure of M1 money, they mean the amount of M1 money in the economy. M1 money was made up of cash, checkable deposits or demand deposits, and traveler's checks, right? So let's say this all adds up to 900. You've got 300 in cash, 300 in checkable deposits, 300 in traveler's checks. If this gets converted to this, and he goes to 0, and this becomes 600, 300 plus 300 is 600, the amount of M1 money is still the same. So in this case, if demand deposit counts as M1 money and cash represents M1 money, then there is no change in M1 money, right? It just changed composition. So since this is my land bank and this is Luis, I'm going to say nada. I'm going to keep the Spanish thing going. How would I explain it? I'd say there's no change in the amount of M1 money, only the composition of M1 money. That's a sufficient answer. You can go on and explain that demand deposits and cash are both M1 money. That's up to you. Part 3 is where we have to differentiate between reserves, required reserves, and excess reserves. As a result of the withdrawal, what is the new value of excess reserves on the bank balance sheet of Meterra Bank? All right. So how did I solve this one out? I went like this. I took I made a total reserves. I'm going to ignore everything else right now. I'm going to say my reserves equals 15 grand. So I took required plus excess equals 15. My demand deposits were 100 grand. Luis pulled out 5,000. That means my new value of my demand deposits is $95,000. $5,000 has to come out of here first. So my reserves are broken up into two parts. I know that this is 10,000. So my reserves are now 10,000. So I can solve for my required reserves. You can't even see this. Demand deposits was 100. My reserves were 15. Now we can all see it. 5,000 came out for Luis. 5,000 came out. So my reserves are now 10,000. My demand deposit is now 95,000. I need to break this total reserves into required reserves and excess reserves to answer this question. What is the value of excess reserves? So required reserve, excess reserves. Total reserves are 10,000. This economy has a 10% required reserve ratio, right? We already solved that because required reserves was 10%. This is 100,000. So what is 10% of 95,000? 9,500. My total reserves is 10,000 and my required reserve is 9,500. 10,000 minus 9,500 gives me excess reserves of $500. So what is the new value? $500. The next question we can't answer yet because we haven't gotten that far. That's the end of today. Please, please let this work. Mental health won't let me do it again. I'm gonna gently move this over here and see if I can press stop. Please work. I beg you, please. The turkey calls.